Super. Yeah. All right. Well, hello everyone. My name is Jeroen Kruijf. I'm a solution engineer at Auth0. And today I want to talk a little bit about building trustworthy AI. I know I'm not the first one to talk about this today, and I sure as hell won't be the last. But there's a good reason for that, and that's because we see a fundamental shift in the way we approach software and the way we communicate with our own businesses and with third-party tooling. So how is this fundamental change happening? Well, of course, a couple of years ago, we saw the massive adoption of large language models, things like GPT, Gemini, Claude. And at first, these were just fancy chatbots. You know, they're trained on a whole lot of data. You can ask them a question, and they will give you a summarized response back. Nowadays, especially the last couple of years, we see a massive shift happening towards agentic AI. Agentic AI can turn any human language into a programming language. It can help us eliminate repetitive tasks across multiple tools and APIs. It can run autonomously with or without user interaction. And it can coordinate multi-flow workflows. So this is what a common modern agentic AI architecture looks like. You have the user prompt that's going to ask something like, show me this specific stock price. You have an agent orchestrator tool that is going to list the tools available to the agent and provide the one that it needs at that moment. Tool execution proceeds. The third-party tooling is either performing an action or retrieving data, and the application then returns the result and shows it to the user. This opens up a whole new world of possibilities, but it also opens up a whole new world of risks. So what about security? Since the whole digital world is fundamentally changing, we also need to rethink security. We need to rethink what it means to be authenticated and what it means to be authorized. And that's because it now won't just be people interacting with our software. It will be agents on behalf of those people. So this whole new world of risk is greatly shown in the OWASP LLM Top 10. OWASP is, of course, a open source project that researches specific security topics. And out of this list, these are the 10 most urgent risks and important ones that we see around large language models. Things like prompt injection, where attackers use special prompts to make it ignore previous instructions. Sensitive information disclosure, where an LLM can unintentionally leak data from its training set. Supply chain attacks, where the LLM is compromised through its external dependencies. Data and model poisoning, where attackers corrupt the training data to create security holes or biases. Improper output handling, where the LLM output is not properly checked, creating vulnerabilities when used by other systems. Excessive agency, where the LLM is given too much power, leading to unforeseen and possibly harmful actions. System prompt leakage, where the LLM is tricked into exposing its own secret instructions. Factor and embedding weaknesses, where attackers exploit the way LLM represents data to discover and abuse flaws. Misinformation, I think this is the most commonly known, also outside of the developer community, where an LLM can spread very convincing yet false information. And of course, we have unbounded consumption, where a large language model can use too many resources, leading to either service disruptions or high operational costs. Out of these, a couple are inherent large language model and AI issues. These are not within the scope of a general AI app developer. Some of these issues, though, do arise within agentic AI applications and do need your utmost attention when building an application like this to make sure you're not vulnerable. Today, I will be focusing on these two topics since they have a very huge attack surface and can have a major impact on your business and on its users if done incorrectly. I will be showing some code examples of tools that we offer, and at the end, if time allows it, I have a simple demo I can show. So, what are the pillars of a secure AI application, right? So, how can we approach this new form of identity? To secure an application like this, there are 4 main engineering problems you need to face. This is first off, authentication. The AI needs to know who the user is. I won't focus too much on that today, since I'm in front of a lot of front-end developers, so I hope you already know. But what I am going to focus on is that the AI needs to call APIs on the user's behalf. So it's going to need access to access tokens. The AI might want to do something sensitive. So you want some form of async user interaction in some cases. And I think most importantly, you need a good authorization model behind this agent to make sure that it considers the user's permissions before either performing an action or returning data. So, since after the user is authenticated and you now want your agent to do something on your user's behalf in some third-party software, you have to understand the right way to do this, and to understand this we need to know what tool calling is. So when you build an agent, you basically provide the large language model with a list of tools it can use, and it's basically a schema of the functions that it's allowed to run. The LLM, of course, itself doesn't execute the code. It just replies and says, hey, based on this user's prompt, I need the Google Calendar tool, for example, with these parameters. So it's your own underlying code, your own backend, that is supposed to execute the API call. And this is the exact moment that you're going to need the access token, right? You want just-in-time access. The agent shouldn't hold the token. The execution layer should fetch the token right before the request takes place. Why? Well, an approach we see some developers take is that the user logs in with Google, for example. They grab the OAuth access token and the refresh token. They hand them over to the agent's memory or the app's local state. And this can have terrible consequences. And there are 2 main reasons for this, and that's both security and state management. From a security perspective, especially when you expose tokens to your agent's memory, as the OWASP top 10 LLM list clearly shows, LLMs are susceptible to things like prompt injection, where they can convince the agent or the LLM to start showing access tokens. You can imagine that if a threat actor gets access to such an agent and it starts exposing its access tokens, this is a terrible situation. And they can have access to the external accounts. So, secondly, you don't want to have to do the state management, especially if you're going to build an agent, which we see more and more, that have a lot of third-party integrations. This means that you're going to have to manage all of these access tokens. Access tokens are inherently time-bound most of the time. So this means you need also to store those refresh tokens. You need to keep track of these access tokens and make sure they stay active and up to date. To solve this, we've come up with a feature called Auth0 Token Vault. And what this does is that instead of your application doing these OAuth handshakes, storing refresh tokens in your database, writing custom grunt jobs to refresh these tokens, you can abstract this away. So with Token Vault, the access tokens are stored at the identity provider level. So when your agent's execution layer is actually or needs to call a specific API, it simply makes a server-side request to the Token Vault saying, hey, I need a connection to this user's GitHub account, for example. Default then checks if the token is still valid, refreshes it if needed, and it will return a short-lived federated token for that specific use case. This means you can use the token in your execution layer, dispose of it right away, which means you don't have to store it on your end for too long, preventing a lot of these types of leakages. So this also means you don't have to worry about the token handling yourself. So this is what it looks like code-wise. So instead of having to first check if the token is still active, refreshing the token if needed, you can just call the get access token for connection endpoint in the Auth0 SDK, and you will get an access token for that specific thing you're trying to do. You can do the thing you're trying to do and then get rid of the token. So less code and zero token handling. All right, so like Rijk, the previous guy already told, for some situations, you want to make sure that what the agent is trying to do is actually what the user wants the agent to do. And if you're working with a front end, like you have a chat window, which are often most agent applications, you can ask it in the application itself. But in some cases, these agents might run on the background. You can ask an agent to do something, and it will happily crunch some data for you. You're going to do something else, and in about 20 minutes, the agent is going to come back and say, hey, I have summarized all this information, and now I want to perform this specific action. So this is where you want to implement something like a human-in-the-loop framework for actions that have real-life consequences if done incorrectly, like sending emails, purchasing products, or booking appointments. A great way to do this is using Auth 2.0, the Auth 2.0 extension called CIBA, which is Client-Initiated Back-Channel Authentication. And if you think about a standard OAuth flow, like the authorization code flow, for example, they rely often on a browser. So you have a browser, the user clicks a button, they get redirected to an authentication page. After they're authenticated, they get returned back, and so that makes it a front channel flow. AI agents, like I said, can run autonomously. So they can run on a backend server with no immediate need for an interface. CIBA is specifically designed for this use case where it's a back-channel flow, right? So the agent's backend server is going to talk directly to the authorization server, and it's going to say, hey, I need this user to approve this specific action. It's going to reach out via an out-of-band device, something like a smartphone. And if you combine it with another OAuth standard, which is called rich authorization requests, you aren't just asking to approve something, you are actually providing context about what the agent is trying to do and to check if that's in line with the user's expectations. This is an example of what it looks like code-wise. This is again using an Auth0 SDK. So it basically functions as a sort of wrapper around your sensitive action. You call this function, and it will wait until the user either denies the request or approves it, sending a contextual information about what the agent is trying to do. This one is simplified, obviously. This one is just going to wait indefinitely until the user approves, so you might want to add something like timeout, but you get the idea. So, lastly, there's one more thing that's very important, and that's the authorization part. Right, so how do you make sure the agent does not overreach the original user's permissions? So an inherent limitation of large language models are often that they are trained on public data. They often do not have, hopefully, a lot of private information about your specific use case. So if you're, for example, trying to build an agent for within your company to gather docs or to do certain specific actions that are relevant to your specific use case, you have to provide that information on the fly. There's a very popular pattern used for this, which is called RAG, Retrieval Augmented Generation. And this is where you can enhance the initial prompt with your own information coming from either a CMS, a database, or a vector store. And you can provide this back to the LLM. The LLM can then, based on that information that you're feeding it on the fly, perform a certain action and return a contextual response. This pattern itself does not inherently take into account a user's permissions. Right, so you still need to make sure that the data that you're going to feed this LLM is specific for this specific user and does not go out of the bounds of that specific use case. For smaller applications or smaller use cases, you could do something like role-based access control. right? So you can assign a user a specific role, and based on that role, you can see specific information or get specific data. However, what we see in practice is that in a lot of the cases, this is way too coarse for something like an agentic application. They often have access to a wider range of data with varying levels of authorization, like read-only, commenter, or editor, whatever. So this often requires a more fine-grained solution. What you could do is implement relationship-based access control, or FGA, which stands for fine-grained authorization. I'm going to talk about OpenFGA today in particular, which is an open source variant of FGA, which we built, which is free to use. So what it does, it lets you control access at a granular level. So access can be granted per object, by document, or by hierarchy, which is ideal for RAG systems that have to access documents like from a file system or a CMS or a database. So you can use relationship-based access control for role-based access control and attribute-based access control use cases as well. But on top of that, if in the future you're going to upscale or it's going to get more complex, it's very scalable. So it will grow with your specific application. If you start off with something like role-based access control, it can be very difficult to then build it to something that's more granular when needed. So how does this work? In FGA, there are three main concepts, which is the FGA store, which is used to organize the models and tuples. You have an authorization model, which is used to define the permission model of that specific system. And then you have relationship tuples, which are either a base tuple or a triplet, consisting of a user, a relationship, and an object. OpenFGA then comes with a couple of APIs. One is check, which will just return true or false whether a specific object or a specific user has a specific relationship with an object. You have the list object endpoint, which will return all objects with a given relationship that a user has a specified relationship with. And then you have the list user request, which returns all users of a given type that have a specific relationship with an object. Sounds pretty complex, and it can get very complex, but in essence, it's not that difficult, right? So this is what an FGA model looks like. This one is a very simple model to define different levels of permissions on documents where users from different domains can have access to these documents. So first off, you have the type definition of a document. So this is the item you want to protect. It has a list of possible permissions like editor, commenter, viewer, and it can be assigned to either a specific user or a group of users. The group of users can be defined by assigning users to a specific domain. So you can say it's a way to bundle users together, so you don't have to assign every permission to every specific user. You can also assign users to a specific domain. And then, of course, you have the user, which is the person you're actually trying to give access. In this example, it's called type user, but you could also, for example, have a type like agent if the agent needs to do something on its own. So this comes together in the bottom where you see a relationship tuple, which is actually defining that user N is an editor of the document called new roadmap. Right, so this is very flexible, and this allows you for very fine-grained control over your permissions. So you can use OpenFGA for this. So OpenFGA is an open source authorization system. It's built by Auth0, and it's based on a very similar concept called Zanzibar, which is Google's authorization model, which Google still uses for all its larger products. If you think about it, you can really apply this to something like Google Drive, where you have folders. If you have access to the top folder, you automatically have access to all the folders under it. But you can also give specific access to a specific file in a folder, right? So it's very fine-grained, and you can give very specific authorization when needed. We also offer a hosted version. That's Auth0 FGA, and this is where uptime, redundancy and high availability is very important for use cases that require those specific elements. So for the demo, I built a little, let's see how I'm going to get my cursor over there. There it is. So what I built is a simple banking assistant agent in Vue. I say built, but I vibe coded it, of course. Sue me. So first I'm going to authenticate using Google. And here we have the agent. And so the agent has a couple of tools listed, right? So it has access to a couple of tools. In this case, I'm going to ask it to show me my accounts, and it's going to happily return the accounts that I have Vue access to, using Auth0 FGA to determine what my permissions are. So what I'm going to do now is I'm going to enroll myself in MFA. This is where the SIBA part comes in. For this specific implementation, I chose to use the Auth0 Guardian application, which is an application we offer that supports push notifications with SIBA. We also have a Guardian SDK, which allows you to build your own notification system in either native applications, so we support things like iOS or Android. We also support it in front-end facing applications as well. So I'm going to get to the application again. So now that I've enrolled myself, I'm now able to transfer money from one account to another. So I'm going to ask the agent again to transfer 100 from my checking account to my credit card. As you can see, I'm a bit behind on my payments. So it's going to send this request. It's first going to summarize if it understood it correctly on the front-facing side. I'm going to say, yes, please, continue. And then it's going to call that specific tool. That tool is protected using our SDK, using SIBA. It's going to send a push notification to my device, also using that rich authorization request protocol that OAuth supports, giving me the exact thing the agent is trying to do in the application, and the transfer can go right through. Now, I can also be a little bit cheeky. I know that my manager is not in the room today, so I'm going to try to transfer some money from my corporate credit card to my own to get a little bit of my debt cleared. So it's going to again summarize first if it understood correctly what I'm trying to do. And as cheeky as I am, I'm going to say yes. And then, since I'm using Auth0 FGA, it's going to check real time if I have that specific relation with that specific account. In this case, I don't. Thus, the request will fail. So, that was a very simple demo. Let's see. If you want to build something like this yourself, I have two QR codes here on the screen. One is just for a quick start guide that's going to help you get started using Auth0 for this specific use case. But the other QR code is for our virtual dev camps. There are two scheduled. One is just a general introduction to Auth0 and what we do. And the other one is a specific agentic AI dev camp. So we are going to be there. We're going to walk you through what you can do to build such an application. It's actually very similar to the banking assistant that I built in Vue. And you can learn how you can protect that using both FGA, token vault, and the authentication. All right, so yeah, that's it. Thank you very much for joining today.